Ladies and gentlemen, I'd like to welcome you to the Testing in Django talk presented by Carl Meyer. This will be a 45-minute talk. At the end, you have questions. I would appreciate if you could come to this microphone right here to ask them. Thank you very much.
Thanks. Good morning. I'm Carl Meyer. You can find the slides for this online. The code's online, so if you see something and it goes by too fast, you can always find it. I should say a couple things before I start the talk. There is going to be a lot of opinions in this talk about better ways to do testing. I'm not a certified expert. I don't have any letters anywhere in my name that indicate that I know what I'm talking about. I'm just a guy who writes a lot of tests. So you should probably come up and argue with me about it afterwards. Also, my opinions, of course, don't represent the opinions of other developers of Django or anything like that. It's just what I happen to think. A lot of the code examples in here are going to be using the new Django 1.4 RC and features in it. So that's something you should be aware of if you haven't tried that out yet. So let's begin with starting a project the way we Django people do. This is actually already using a new Django 1.4 feature. Can anyone spot it? It's about the size of one period. It's the ability to start a project in the current directory instead of creating a new subdirectory. And I don't normally edit my settings files using sed, although that would be really cool if I did, but it goes on a slide better than opening up an editor. So I'm just setting the database backend to SQLite for my new project. I'm going to run manage.py tests. This is like the default Django testing experience. I've just started a project, and I'm running manage.py tests, and what happens? Well, I've snipped it because it's really long. But actually what happens in 1.4 RC is two failures, which kind of means we aren't quite ready for the final release yet. It also illustrates the point I'm about to make really well, which is that ran 412 tests, and it took 14 seconds to do it. That's using an in-memory SQLite database, which is the fastest way you can run Django's tests, and it still took 14 seconds. And I haven't written any code yet. I haven't written any tests. I haven't written any code to be tested. That's not a good thing. Like, we talk a lot about making tests fast. There's no reason for Django to be wasting my time with tests that the Django core developers are the ones who ought to care whether those tests pass or fail. And also, the two failures occurred because two tests were added to Django's contrib.auth application, and they were insufficiently isolated from the project settings. They assumed the existence of two databases configured in the settings. When we run the Django test suite, we have two databases configured in the settings, so those tests pass. So we never noticed this before releasing the release candidate. When you run it from a fresh Django project, because django.contrib.auth is in installed apps, it runs those tests. It doesn't have the other database, and that's why those two tests fail. There is a difference between an app that you create in your project for your site, and you write the code and you write the tests, and one that's either built into Django and Contrib, or one that you pull down off of the cheese shop and install in your project. They aren't the same thing. A third-party app, the only time I care about its tests is when I decide to use it. I might run the tests if I'm being good to make sure that they actually pass. When I upgrade it, I might even run the tests on the new version to make sure they pass. In between those points, that code isn't going to be changing, and I have no reason to waste my time running its tests. And the same goes for the Django Contrib apps. It's a waste of my time to run the tests for django.contrib.auth in my project every single time I run my tests. One argument on the other side says, well, you maybe need a test or two that verifies that your project is integrating properly with contrib.auth. The truth of the matter is that those tests, if they're written in contrib.auth and they aren't isolated, they will usually fail in an integration setup that actually works. Because you can integrate things in so many ways. You can wrap the views and do your own custom thing outside of contrib.auth's views. You can do funny things with the URLs. You can customize it in so many ways that it's almost impossible for contrib.auth, for example, to provide an integration test that will actually reliably pass in your project. So what happens in practice is we write naive tests in contrib.auth that aren't fully isolated. Someone files a bug because the test fails in their project. We isolate it. Over time, those tests get more and more isolated so that they actually reliably pass in any project. And at that point, it's a waste of time for the project to be running them because they aren't testing anything related to that project. They're just testing whether contrib.auth's code works. This particular problem isn't a big problem, right? You can just do this. You can wrap that up in a shell script, and you're done. There's another problem. Django insists that your tests all live in a tests module in each app. Now, if you're writing the amount of tests that you probably should be writing, that's either going to be one big file very quickly, or you're going to want to split it out into tests for specific aspects. And then you end up with something like this, where you have to import every test case from the submodules into your test.py module for no other reason than so that Django will find them. This is 2012. That's ridiculous. And the third issue I'll talk about with the current Django test discovery is that it forces you to intermingle your test code and your non-test code within your project. This depends somewhat on how you structure things. You could make your internal project code all one big app. But if you do want to split up your models into some separate models files, then you end up having to put a tests module in each app. Personally, I prefer to have my code and my tests for my project in two separate places and not have them intermingled. Django's test discovery doesn't give me that choice. Fortunately, Django does make this easy to change. You can use unit test 2 discovery. You could also use nose or py.test or other discovery mechanisms. I'll talk about unit test 2 because it's built into Python, it's built into Django, so it's always there, and it's something that we could potentially do in Django itself. Django has a test runner setting, so this is how much code it takes to make Django's test discovery good. It's not very much. This is just using unit test 2 test discovery. It adds a setting test discovery root. There'd be other ways to do this, but this is the simplest way. And it discovers any tests underneath a certain root path that you specify. This is what you need to do in your settings file to make that work. You figure out what the base path of your project is and set test discovery root to a tests directory, for example, and then you just point it to wherever you've placed that runner class. And we win. Now we can discover tests wherever we want them. We aren't forced to put them in a certain specific module in a certain app. And we can be much more flexible about running exactly the tests we want. We aren't constrained by the app label concept to run all of a given app's tests. We can run a specific test module, so we can say something like, if I have all my tests under a single tests module, I can say tests.quotes.testViews. It's using real Python dotted paths to specify which test, which is much more flexible for getting exactly the tests you want. And I think we may actually get this, something like this in Django 1.5. We have some things to figure out about making sure that people who like the current behavior can still get it if they want it. But there's actually a ticket, it's all accepted and stuff, so we might get there. Okay, before I talk about, I'm going to talk a little bit about testing models and testing views, some different kinds of tests you might write. Before that, I'm going to do a little review of two overarching types of tests. These next few slides are really a much inferior restatement of Gary Bernhardt's excellent fast test, slow test talk from yesterday. So you should really go check out the video for that talk, but I'll try to do it in like 2 minutes here. Here are the two types of tests I'm talking about: a unit test versus a test that type of test that has more names than it needs. System tests, integration tests, functional tests. So a unit test tries to test one piece of code, one unit of code in something like isolation. The advantage of unit tests is that they run quickly and they're focused, so when the test fails, you should know like pretty much within 5 or 10 lines of code what code failed, or even less. So you should be able to go very quickly from a test failure to the problematic code. And unit tests help you structure your code better. When you write a unit test, if you're writing a test for a very small piece of code, you have to think about what dependencies does that code have? What pieces of the world, what state do you have to set up before that piece of code can run and do its thing? And what do you need to check afterwards to assert that it worked? And if there are too many of those in a unit test, that tells you something about your code. And you can say, hey, why does this code need 10 different things to be set up before this code can run? Is there any way I can extract it even more so that I can test an even smaller unit that doesn't require me to set up so much state? Integration tests, on the other hand, are also very important. This is not a better and a worse thing. Integration tests test that the whole system works when you put it together. They tend to be slow because they're running through the entire stack, all your middleware, all your context processors, rendering templates, going to the database. The failures are useful in the sense that they tell you something is broken, and they will often catch brokenness that a unit test won't catch because they catch bugs when different pieces of the system connect. But those failures take longer to debug because oftentimes you can have one thing in your code base broken and all your integration tests will fail, and it doesn't tell you very much about where to go look for the problem. Most people write too many of these, in my experience, Django projects, and end up with very slow tests as a result. Django makes it very easy to just say, oh, I'll just test this with a test client and check that it worked, and you end up with tests that take forever to run and are harder to make use of the results. So you should definitely have these, but chances are you should have fewer than you're writing now, and more unit tests. All right, let's talk about testing models. As much as you can, you want to write tests that don't hit the database. Because Eric Rose, he also had a very good talk about testing yesterday. And he had a great slide, which I wish I had copied, which is showing the latency of going to level 1 cache, level 2 cache, RAM, or going to disk. And it's like level 1 cache, if you make level 1 cache 1 pixel, then it goes up a little more for level 2 cache, a little more for RAM, and the latency of going to disk is like this massive block that goes down into the Earth's mantle. So it's a huge difference between doing things in memory and actually having to go to disk. So Django doesn't make it easy to write tests that avoid hitting the database because the way the model layer is structured encourages you to tie your domain objects entirely to the database representation, which has some advantages, but it means you have to think about extracting out functionality in your domain layer that doesn't actually need to talk to the database and making that separately testable. And I'll give an example of that in the next slide. And that can really make a big difference in speeding up your tests. One thing that some people try is to actually write tests that mock out the persistence layer, mock out the database to make faster tests. My experience is that this is a way to fail. This is not a good way to write tests because database persistence layers are very complex beasts and a lot of things can break and you'll end up writing fragile tests. It's a very, the layer where your models actually talk to the database is not a small and well-defined API. There's a lot of different stuff going on there, and to try to mock all that out reliably is a lot of work and makes your tests less useful. So it's better to try to write your code, try to separate your code in a way that you can write more tests that don't touch the database. Here's a simple example of that, a very simple example. So you've got a method on your model. It does some complicated thing that has many, many code paths and touches the state of the model in lots of different ways. And at the end, you save the model. All right, that's fine. You might want that semantic for the API that you're actually going to use. But it means that you're going to probably, if you're testing this method well, you may write 20 tests of all those different code paths and all those different state combinations that could affect this model to make sure that this method really does what it's supposed to. And every single one of those 20 tests is going to write to the database. And you could probably make those tests 20 times faster if you just do this. Maybe more, depends on which database you're using. Just pull out the code that does all the state modification and all the complicated code paths and make it not talk to the database if it doesn't need to. And then you can write all your 20 tests for that separate method, for that separate function, and just one test that actually tests that, yeah, my actual Frobnicate method does save the model at the end. And depending on the specifics of the code, you may want to make those both methods of the model. It can work either way, or you may make it a standalone function. That's not the key point. The key point is you extract out the functionality that doesn't need to talk to the database from the functionality that does. All right, I got a couple boring slides here so you can fall asleep for these. These are boring because I don't have any problem with how Django does things. I think it's pretty much okay. So the Django test case class runs each test within a transaction, rolls back the transaction at the end of the test, and monkey patches all the transaction functions, so if you call them in your code, they don't do anything. And this makes the tests a lot faster than they used to be in Django 1.1 because you don't have to truncate all the tables or recreate the state of the database between every test. You can just let the database do that with a rollback. The transaction test case, on the other hand, if you subclass your tests from that, allows you to test transactions in your code because it doesn't wrap your test in a transaction. Therefore, it has to flush every database table after every test, and it's really, really, really slow. So, of course, again, you want to have as few of these as possible, only when you really need to test transactional behavior in your code. Another aspect of testing models, or really testing anything in Django, is you often need to set up some database state ahead of time. And currently, the way that the Django documentation points you to do that is with these fixtures. Don't do that. If you've got a bunch of these in your code base, burn them. Problems with fixtures. I think this is probably the third talk now that's discussed this, but just to say it again, fixtures are very difficult to maintain and update. In the naive case, what you're doing is like you're hand editing JSON, that's terrible, or you are having to do this complicated dance where you empty your database, load in the fixture, run some code to modify the state of the database, then dump it out as a fixture, and that takes forever. Or if you're really clever, you might be using something like the Django fixture generator app, which allows you to write code that will then dump out fixtures. But at that point, you might as well skip the fixture step, right? Another thing that fixtures do is they tend to increase interdependence between tests, because if you have a fixture with some data in it for your existing test and you need to add a new test, and your new test really just needs one object in some particular configuration, it's really tempting to just say, oh, I'll just add that into my fixture. And now you've got some test, totally unrelated test, that happens to assert about a count of models, and the new one that you've added now breaks that unrelated test. There's no relationship between the code, but you've introduced unnecessary coupling between the tests by sharing a fixture between them. And also they're slow. Again, because people tend to put more things into them than is strictly needed by every test using that fixture, and every single test has to load that fixture. Now there's tricks you can use to help with this problem. Eric Rose talked about that yesterday. If you've got a huge code base like Mozilla does with a ton of fixtures, those tricks are excellent. If you're writing new code, I think you just don't use fixtures. The alternative to fixtures is model factories. So the problem, if you're trying to, here, before we spend too long looking at that code, the reason you use model factories is the problem with just using the ORM to set up your state in your tests is that often models have interdependencies. So it's a real pain if you have a model that has a foreign key to some other model, has a foreign key to some other model. If all you need is an instance of that first model to test, you might be writing 5 or 6 ORM statements in every test just to set that up. And people don't like to do that, which is why they use fixtures instead. The solution to that is not fixtures. The solution is factory functions that take care of that for you automatically. So this is a very simple handwritten example that you might just write yourself. And it's an example of a user profile model, which depends on having a user model. So what we do here is we set up some defaults. You can pass in keyword arguments to override any of the defaults that you care about. So if you don't care about the age or the address for a particular test, you don't have to specify them even though they're required fields. The factory function just takes care of that for you. And if you don't care about any details of the user that the profile is tied to, you don't have to worry about that either. The factory function just creates a user for you and attaches it to the profile. So you could use it like this. You can just say profile equals create profile. The only thing I care about for this test is the age of the user. I don't care about anything else, so I don't have to say anything else. My test is explicit about exactly the data it needs to be explicit about and no more. And then I can make the assertion I need to make. It's a very simple and clean test. Now, there is one very bad thing about this test, which is that this can vote property on my user profile doesn't require a saved model. All it requires is a profile object, and it checks the age attribute, right? And I've written a test here. If you look back at the factory function, it calls profile.objects.create. So I've actually saved my profile to the database unnecessarily, simply in order to test an attribute of it, a property of it, that has no dependence on being saved to the database. So that goes back to what we were talking about earlier. What you need in order to fix that problem and write tests that don't touch the database when possible is a factory that can either create a saved object or an unsaved object. And that's one reason you might not want to write factories yourself like this. You can do it, but once you start getting into some of the features you want, you might want to use a library. And there are some. The one that I use is called Factory Boy. It's a clone of Ruby's Factory Girl. And this is what it looks like. So instead of writing a function, I subclass factory, tell it which model I'm making a factory for, and just set up some default values for all of the required fields of the model. And I can do this sub-factory thing for a foreign key, so it'll know, this presumes that I've defined user factory somewhere higher up in the code base, and it knows that it can create, it can run the user factory to create a user to attach to the foreign key of my profile. And I don't show it here, but I can call profilefactory.create, and that will actually save it to the database, or I can write profilefactory.build, and it will do the same thing, build a profile, but not save it to the database. So you can be explicit in your tests about whether you need to talk to the database or not. I think we've mostly gone over this, but advantages of factories over fixtures is that your test data is local to your test, which makes your tests clearer and easier to maintain. Your test isn't depending on data that's often some totally separate fixture file. You can see right there in the test, here's where I create the data, here's what the data looks like, here's how I assert about the data. They're easier to maintain. You don't create extra data you don't need for that specific test. And even sometimes people say, oh, I need fixtures because I have these tests that I need to run against this data set with thousands of models, and there are 5 different kinds, and it's a very complicated data set. But you don't need fixtures for that either. You can write helper functions that use your factories to create a very complex data set and use that in your tests. Hopefully not very many tests because they'll be slow. And that works just as well as a fixture and is much easier to maintain. On the issue of not talking to your database if you don't need to, there's a way to impose that discipline on yourself, because Django makes it very easy to not be entirely clear when you're talking to the database and when you're not. So it can be helpful to know for sure, I don't think this entire test case should need to talk to the database, so let me just make sure it doesn't and have my code yell at me if it does. Obviously not for all of your test cases. You're going to need to have tests that talk to the DB. But this is how you can do it. This uses Michael Ford's mock library, which I always use in every project, which is for creating mock objects and patching, monkey patching things for the purposes of testing. And in this case here, we're just creating a mock version of Django's database cursor wrapper, and we're causing that cursor wrapper, that mock cursor wrapper, to just raise an error anytime it's instantiated. And then we patch the actual cursor wrapper class for this test case with our mock cursor wrapper. And so any tests you write in that test case will immediately blow up if you try to talk to the database. Oh, one other subtle thing in this slide, this NoDB test case, I'm actually inheriting it from Django.utils.unittest.test case. Django.utils.unittest is Django's bundled version of the unit test library. So when we import test case directly from there instead of from Django.test, we're getting a bare test case that doesn't do any of Django's fancy database setup and transactional handling and database teardown. In practice, that's not really very important. It doesn't save much time. Django's database layer is smart enough that if your test actually didn't touch the database, it doesn't bother even sending the transaction rollback. So your tests are almost as fast either way, so it doesn't really matter. It doesn't really hurt to import it directly from unit test if you want to. Okay, moving on to testing views. We talked about unit tests versus system tests. Views are some of the hardest code to write unit tests for, and the reason is view code in Django is where everything else comes together. They have many collaborators or dependencies. So views, they get the request, they usually use templates, they usually talk to the database. Pretty much everything else in your Django project comes together in your view code. And that means that if you're going to write an isolated unit test, you have a lot of things that you need to set up yourself to allow that view code to run. Yeah, they depend on your middleware sometimes. The real solution to this is to write less view code. One of the most common issues I see in Django code bases is views that have too much code in them. Because views are hard to test, you should work really hard, and because they know so much about everything else in your system, it's very tempting to put code there because you don't have to think about the dependencies of your code. You can just thoughtlessly write code that requires everything in the world. And if you write less view code, it forces you to pull out pieces of functionality and think about what does this code actually require? Does it actually need the request? Does it just need some specific bit of information from the request? And pull that out into something that's much more unit testable and shrink your view code. I don't like to see a view that's longer than like 10 lines, 12 lines of code. If you do unit test your views, here's some things that I do. I don't know if you've seen Request Factory. It doesn't get a lot of publicity, but it's a very useful piece of the Django test support code. It allows you to construct a fake request, basically, with a certain path and maybe certain post data or whatever. And if it's a unit test, you're not going to be using the Django test client. That's not a unit test. As soon as you're using the test client, it's exercising your entire system through the URL routing, through the middleware, through your everything. That's not a unit test. A unit test for a view calls the view callable directly. And also, a side effect of that is that you're going to have to set up your dependencies explicitly for that test. You're not going to get request.user magically. You're not going to get request.session magically because it ran through your session middleware and your auth middleware and all of that. You're going to have to manually put those things onto the request object. So here's what a unit test of a view might look like, a relatively simple one. We use Request Factory to create a post request. This is a hypothetical view that changes the locale by setting a session variable. And we want to test that it actually does this. If you post to this view, should be a post, of course, because it's changing state, so shouldn't be a GET request. If we post to this view, we want to test that it actually does set the new locale into the user's session. So we create a request. The API for Django's session module is essentially a dictionary API. Now, technically, it's a little more than that. If your view is doing something odd that it probably shouldn't, like calling request.session.save explicitly, this wouldn't work. But for most uses of the session, it's effectively a dictionary. So we can just fake it. We can just stick a dictionary onto the request, explicitly setting up that piece of that dependency of the view. It depends on there being request.session. Then we just call the view function directly, and we assert that request.session got the new key in it. Very simple. That's what a unit test of a view looks like. Or you could just not do this. I don't very much, to be honest. Ideally, maybe every piece of code in your project would be covered by unit tests. I find it a better use of my time to work on writing very simple views and cover them with my system tests and focus on unit testing other parts of the code base. Your mileage may vary. So here's the other side of testing views, what most people actually do. Integration or system tests. Talk about a couple specific issues with that I see commonly. Here's an example of trying to test a view using the Django test client, and this is a view that processes a form set. And so this is the kind of thing you tend to see. You're posting to the view, you're posting to that URL with all this stuff, including a bunch of things that are actually sort of implementation details of form sets that end up being hidden inputs in your template, like total forms, initial forms, max num forms. When you write a test like this, and somebody edits your template and forgets to put in formset.management form, a very easy mistake to make if you have a manual form layout. Your form doesn't work anymore. If somebody actually tries to load it in a browser and submit it, it will fail because it doesn't have the required stuff. But your test specified all that manually, so it won't fail. Your test will keep passing. And this is because the Django test client, it's missing some features, in my opinion, that make it fall into a sour spot in between unit and system testing. It's not a very good system test because it's very easy to break this view with a simple template change and your test won't catch it. So you aren't really testing the system end to end. It's also not a unit test because you're going through way too much of your code. So it's halfway in between, or it's a bad system test. The alternative is to use something like web test. That's a library written by Ian Bicking, and it has a couple advantages over the Django test client. One is that it knows a lot less about Django, which is a good thing because it means it builds in a lot fewer assumptions and it just talks to your app over the WSGI interface, which is, not coincidentally, more like how all of your users will be talking to your app. So it can do less complicated special casing of things in Django, and it's a little more naive, and that's a good thing for making you write good tests. It also is smart about HTML, and specifically for testing a view like the one we just looked at, it allows you to write a test that is much easier to write and more effective of a test, which is a nice combination. So this is essentially the same test we just looked at using the test client, except using web test. And because web test is smart about HTML, it'll actually parse the actual form markup in your view output, and it can submit it back just like a browser would, and it allows you to set the values for certain fields. So in this particular test, if you look carefully at what I've done here, all it's really testing is adding a new step. There's an existing step for this, hypothetically a test case with steps. That's confusing, but all you're doing is adding that steps 1 step and steps 1 expected. All the rest is boilerplate. And with web test, you don't need that boilerplate. You just say, fill in these 2 fields on the form and submit it. People disagree about this. I think specifically with views that handle forms, it's very easy. In fact, possibly one of the easiest way to break those views is with bad templates. So if bad templates are the easiest way to break a view, your tests ought to be testing that template. It ought to be testing that markup. A very common pattern with the Django test client is people punt on testing the markup at all, and they just test that a certain template was rendered and with a certain context. From my perspective, the template being rendered and the context that was used are an implementation detail of the view. The view, when you're system testing a view, it takes as input a request, and the output is an HTTP response with probably an HTML body. And ideally, those are the things you should be testing, those inputs and those outputs, and not the implementation details of how that response was generated. Of course, you have to be smart about this. You don't want to be testing irrelevant details of the markup that some designer is likely to change that won't break anything but will make your test fail. So you have to test the things in the markup that actually could make or break the functioning of that view, like form markup. When I say system tests are easier and faster to write, I mean with web test versus the Django test client. There's also a project called Django Web Test that provides integration between Django and web test. There's also a couple other nice features of web test that make it easier to test the markup output from your views. It builds in beautiful soup or LXML and also JSON parsing. So you can easily test a JSON response without having to parse the JSON yourself. You can use beautiful soup or LXML to test the HTML that comes out of your view. The last layer of testing I'll talk about that's even higher level than something like web test is, of course, in-browser testing using something like Selenium. In Django 1.4, Selenium testing just got really, really easy. This is, I think, one of the greatest things about Django 1.4, and there's a lot of nice things in Django 1.4. This is what it takes. You pip install Selenium, the Python Selenium driver, and you inherit from live server test case, which automatically takes care of running a server in a separate thread that your Selenium tests can talk to. Normally, setting up in-browser testing is a little bit fiddly because you have to first get your site running on some port and then tell Selenium which port it's running on and point it at, and that takes a little bit of setting up. Django just does all that for you now in 1.4. So here's an example of what a Selenium test could look like. This is testing in Firefox. Selenium comes with drivers for several different browsers, so you could import web drivers for whichever browser you want to test on. And you've got a Selenium test. You can stick this in your tests and run manage.py test, and it will actually fire up Firefox and run through the steps and pass or fail. It's very nice. So here's my rules of thumb on what kinds of tests to write and how many. And this is something where it's going to depend a lot on your project. You may have different opinions. I think you won't go real far wrong if you do something like this. Write system tests for your views. Write the Selenium tests that you need to test interactions between client-side code and server-side code. Write as few of both of those as you can. I'll show in the next slide what that looks like. And everything else, write unit tests. And I'm not super strict about what a unit test is. For instance, if I'm unit testing a model form, I probably won't mock out the model because model forms and models are very closely tied. So I'll just go ahead and let that model form collaborate with the real model, but I'll still call that a unit test. I'm trying to focus testing on a specific part of the model form. So it's not super strict, but they still tend to be relatively fast tests. And one guideline that I find very helpful is to think about testing each branch in your code at the level where that branch occurs. This may seem obvious, but I see a lot of tests that don't do this. So the next slide will go a little more in detail into that. Another guideline, this depends on how strict you want to get. One assert per test case method or one action per test case method. One assert per test case method is very strict. Ends up you write a lot more tests, but the tests will tell you very specifically what failed. If you have multiple asserts, of course, the danger is your first assert fails and you don't know whether the second one would have failed or succeeded. So you fix the first one, you run your tests again, they fail again because the second assert failed. You have a longer cycle to fix those tests. I don't stick strictly to a single assert per test case method. I try to make sure that each test case method tests one action and then maybe asserts a few different things about the results of that one action. What you really should avoid is multi-step tests. They're tempting to write because you don't want to do your setup multiple times. So you do one thing and then you make a little tweak and then you assert some more things, then you take another action, you assert some more things. Those tests end up becoming much harder to figure out what failed and what you need to address. All right, so here's an example of the fourth guideline there, testing each case where it occurs. This is a view. If I were looking at tests for a Django project that contained this view, there's a very typical Django form handling view. It constructs a form, it redirects if the form is valid, et cetera, et cetera. I wouldn't ever want to see more than 3 tests at the system level for this view because there's 3 code paths. You have the first time load, you have the submitted with errors, and you have the submitted successfully. Those 3 cases cover every code path, every branch in that view. You'll have 100% branch coverage in that view with those 3 tests. If you have some special handling, like in the quote form or in your quote model, that like there's some specific validation, these 2 fields have to both be there, or the values depend on each other, you don't test that with a test using the Django test client or using web test at the system test level, because that code isn't at this level. You test that special case in a unit test of your form class or your model class or wherever that case occurs. The only system tests you write are the ones that are reflected in branches of your view code. All right, going in a totally different direction for the last couple minutes. We had a whole series of commits in Django leading up to Django 1.3 with a commit tagline, "We have always been at war with doc tests." Early on, Django itself was tested very heavily using doc tests. I'm assuming that you all have seen doc tests or know what they are. They are a way to turn a Python code example in a text file or a doc string into an executable test. I won't go into detail as to why it was a problem to do too much testing with doc tests. Just say that the hatred of doc tests in the Django community at this point is not entirely fair. Doc tests are great for testing your documentation. And it's a lot easier than most people think to integrate that into your Django test suite. So you have Sphinx docs, right? The answer is yes. And you probably have some API code examples in your Sphinx docs for if you have a Django library or something, or even for your project. And this is all the code it takes to turn those API code examples in your documentation into tests that will actually run and verify that your code examples stay up to date with your code. You just instantiate a doc file suite and point it to a Sphinx text file that has some code examples in it, and it'll just work. If you go too far with this, you can very quickly have bad documentation. If you start thinking of them as tests of your code and trying to put every little edge case and odd situation into these doc test files, you're going to have bad documentation. The point of this is to have good documentation and make sure that it's not getting out of date with your code. One last thing, just because it's a nice new thing in Django 1.4. You have a setting in your code, we'll say it's called allow comments. This is the way people always used to do testing that depends on a certain value of that setting. You want to do a test that comments are allowed when the allow comment setting is true. So you have to do this whole try finally thing. You could use mock, that would be a better solution than this. In Django 1.4, you don't have to use mock because we actually have an override settings decorator that handles this particular case quite well. So that can make some of your tests nicer. That's all I got.
I would like to ask if you have any specific comments on any of the various Django nose modules that are around.
I've used Django nose. I think that's the main one. Personally, I'm pretty happy with Unit Test 2, test discovery, and the way it does things. I don't have major pain points that nose solves. I know some people do, so I don't have a strong opinion about that. I think Django nose works fine. Django's test runner setting makes it pretty easy to swap in whatever test runner you like. So,
do you have any times where you feel you need to test the form set implementation, like you don't want to go through a full system test with Selenium, but you want to actually test something that's in a view?
Well, if I'm testing something in the form set, I would want to test it with a unit test of the form set class.
More
ideally.
something that requires the interaction between the form set and the view.
So like,
or is that, do you think that's just a code smell and it needs refactoring?
I'm not sure. I'm not sure what kind of situation you're talking about. Like,
well, do you think there are situations where that's a reasonable a way to go about it, or do you think the second you start putting total forms in your test suite, that's a sign that you need to look at refactoring?
No, you might have to put total forms in your test suite in a unit test of a form set class, a custom form set class that does some custom things. I wouldn't want to see it in a test of a view. Okay. The exception for that is like if you have JavaScript that's like dynamically adding new form set classes, or new forms in the form set. First of all, you'd want to do the basic test for that in Selenium to test that the JavaScript actually works. If you have some edge cases in the server-side code that's handling like different cases where maybe the initial forms or total forms comes in with the wrong numbers or whatever, that should be tested in unit tests of the form set code that's handling that. So you have some unit tests of the form set code to handle all those edge cases, and you have a few Selenium tests to test that the whole thing actually works with the JavaScript. Does that make sense?
Yeah. Okay.
First of all, I'd like to thank you for your work on pip and virtual env. I can't say like how much time and headaches those two tools have saved me. So my question is, like any a good developer, I try not to repeat myself, so I try to make reusable apps whenever I can. Do you have any general advice on how to test like these modular apps? I mean, especially if I intend to put them on PyPy.
So my advice on testing reusable apps in Django: one, don't make the mistake of actually putting the tests in the test.py of your app, because then you'll trigger the problem where everybody else is running your tests when they don't need to be. Instead, put them in like a separate directory that you can, and then have a test runner just for that reusable app. It's very easy to write like a 10-line test runner script that sets up the settings that your test for your reusable app needs, and can set up installed apps with something that isn't really an app but happens to have your tests in it, just to sort of fool the default Django test runner into actually running those tests for your app. And then other than that, I don't know. I'd have to have more specific questions, but